Welcome to a video for section 3.6 on parallel and perpendicular lines. Specifically, we're going to talk about the rest of this foldable that we started in class, where we are going to look at how to write the equations of parallel and perpendicular lines given various information. So we are doing this part and this part. We already completed talking about what parallel lines are and what perpendicular lines are. Okay, so just to remind you, parallel lines have the same slope, so they do not intersect. That's the key idea. So in our first example here, what we want to do is write the equation of a line that is parallel to the line y equals 5 halves x plus 7 and passes through the point -6, -1. So let's just take a moment to visualize what exactly we're talking about here. So there's this point, -6, -1, which is over here. Let's make this a little bigger. And we have a line, y equals 5 halves x plus 7, which is not the line we want. Let's put the x in the right spot, but a different line. And what we want to do is create a line, or find the equation of a line that is parallel to this. So from this blue line, all we need to know is the slope, because parallel lines have the same slope. So that tells me that I'm going to have a line that's going to be parallel, so something like that. Okay, so let's do it. We are going to start by borrowing from the other equation the slope, which, since this is in slope-intercept form, the slope is 5 halves, and we're just going to use that slope. So I'm going to go ahead and write y equals 5 halves x plus b. So mx plus b, except I don't know what b is. Alright, now this 7 was the b for the other one. That has nothing to do with our problem at all. That number could be anything, and so I want you to just ignore that number. So that's 7, just ignore it. We don't use it. So now we're going to do just like we did before, where we're going to find the slope using the point we're given. So this is your x1 and your y1. So we're going to plug them in. So the x1 is going to go where x is, and the y1 is going to go right here. Okay, let's see what we get. So that would be -1 is equal to 5 halves times x, which is -6, plus b. Don't be afraid of the fraction. Put the whole number over 1, and let's see if we can cross cancel. Does 2 go into 6? Yes, it does. 2 goes into 2 once, 2 goes into 6 3 times. So don't forget the negative though. So this is 5 times -3, which is -15, plus b equals -1. We're almost done. We are just going to add the 15 to both sides to get the b alone. So add 15, add 15. -1 plus 15 is 14. So our b is 14. And so our answer is y equals 5 halves x plus 14. Going back to our graph, just to show you that this works, I'm going to type that equation in, and you can see that our line is parallel to the blue one and it goes through this point, so it works perfectly. Okay, example 2 is a little bit different, and the big difference is when you look at the equation that they give you. Well, let's read it. Write the equation of a line that is parallel to the line 2x minus 8y is equal to 8 and passes through the point -12, 7. So the big difference here, and this sometimes happens, is that they don't give you the line in slope-intercept form. Do you know what form this is in? If you said standard form, you're correct. So the first thing we want to do is actually put it into slope-intercept form so that we can find the slope that we need to use. We want to know what the slope is, and this form doesn't tell us the slope. So that's our first step. Okay, we've done this before. We learned how to do this in 3.5. So let's go ahead and subtract 2x from both sides. Negative 8y is equal to, I'm going to put this negative 2x in front of the 8, and then I'm going to divide everybody by negative 8. Okay, so this line is, well, let's clean this up. Negative 2 divided by 8, negative 8 is positive 1/4. And then minus 1. I don't care about the y-intercept of this at all. I'm just looking for the slope. There it is. It's 1/4. So now I'm going to use that slope, the exact same slope, just like it did before. So I'm going to plug that in for m. I don't know what b is. Okay, so now I'm going to do the same thing I did with the point. I'm going to plug in negative 12 for x and 7 for y. Okay, so that would give me 7 equals 1/4 times negative 12 plus b. Let's put this over 1 and see if we can cross cancel. Yes, we can. Be 3. So 7 equals negative 3 plus b. Add the 3 to both sides. So the b is 10. So putting it all together, we have a slope of 1/4 and a y-intercept of 10. And that's the equation of the line. Alright, so now for the second half of this, we're going to do sort of the similar idea except with perpendicular lines. So remember, perpendicular lines have slopes that are opposite reciprocals. So the word opposite means they have a different sign, so they change sign. So if one of them is positive, the other one's going to be negative. Then the word reciprocal means to flip it over. So if it's 4/7, then it's going to be 7/4. Another thing that I don't think I mentioned before is if you multiply these two slopes together, the product will always equal -1. And I'll just prove it to you. 4/7 times -7/4. By the way, your example may vary. Okay, so whatever numbers you had, this will still work. The 7s will cancel, the 4s will cancel, and when everything cancels, you just have a 1. Except there's this negative here, so it's a -1. So the procedure to finding the equation of a line that is perpendicular to a given line is going to be pretty much the same, except we don't use the same slope. We must change the slope so that it is a perpendicular slope. So let's do example 1. Write the equation of a line that is perpendicular to the line y equals 1/3 x plus 9 and passes through the point a -4. So your first step is to look for the slope. Our slope is 1/3 because this is in slope-intercept form. But that's not the slope I'm going to use. I must first change this slope. So I'm going to flip it over, change the sign. So if this one's a positive 1/3, so my slope is going to be a -3/1, or just 3. -3. The rest of this is exactly the same. I'm going to plug that slope in to y equals mx plus b. Then I'm going to plug in x, and I'm going to plug in y. Same as before. The rest of it is exactly the same. So -4 is equal to -3 times 8 plus b. -4 is equal to -24 plus b. Add 24 to both sides to solve for b. b is 20. Okay, so we just plug everything in. Remember to use this slope. And you don't have to write it over 1, just write -3. There it is. Okay, so now it's your turn. I want you to try example 2 completely on your own. Okay, Don't forget to maybe rearrange the equation that they give you so that they have it in, so you have it in slope-intercept form. All right, let's give it a try. Okay, looks like the slope of this line is 8 over 5. So what would be the slope of a perpendicular line? The slope of a perpendicular line would be -5/8. You may get stuck on this part where after we plug in our x and our y and we cross cancel, we still have a fraction. So one trick that you can use to get rid of a fraction in an equation is to multiply everything on both sides by the common denominator, which in our case is 2. So I can multiply, as long as I do it to everything, it's a legal move, including the b. And so then when you do that, you get 10 equals, and then here the 2's will cancel and we just have 5 plus 2b. This may feel a little better to work with for you. All right, go ahead and continue. And so we get that the b is 5/2. And so the final answer is y equals -5/8 times x plus 5/2.